In the 1920s, astronomer Edwin Hubble came to work at the Mount Wilson Observatory in Southern California. The observatory offered some of the most advanced technology of the time. Using George Ellery Hale's magnificent telescope, Hubble photographed the nebulae, faint clouds of light that were a mystery to astronomers. When Hubble examined his photographic plates, he discovered a Cepheid, a kind of star that varies in brightness over a period of time. Hubble studied the variation in brightness and used the data collected to calculate the distance to the star. By his calculations, this star and the galaxy it's a part of were much further away than anyone had ever imagined, and the universe was much larger than the Milky Way galaxy.
What he found was that the distance to M31, the Andromeda galaxy, one of, turns out, our nearest neighbors, is about 2 million light years. So people have been talking about the scale of our galaxy, 10,000, 20,000, 30,000, maybe 100,000 light years. What this meant was that M31 and all those other galaxies were not part of our system. They were themselves big systems equal to the Milky Way.
Scientists now know that there are billions of galaxies, and each galaxy has hundreds of billions of stars. Hubble's discovery of the stunning size of the universe and the massive number of star systems within it revolutionized our picture of the cosmos. That discovery alone would have made Hubble one of the great astronomers, but he continued to study distant galaxies and made an even greater discovery. For 5 years, he gathered data on the movements of galaxies, recording their path and direction by studying the wavelengths of light. Different wavelengths of light appear as different colors of light. If a galaxy is moving away, its wavelengths of light are lengthened. This light appears redder. The faster the galaxy is moving away, the redder the light. If a galaxy is moving closer, the light wavelengths are shortened, so the light appears bluer.
After many years, Hubble could sit down and look at this great quantity of information, and he plotted a chart. He plotted for the nebulae the motions against the distances, and he found something truly amazing, a straight line.
He found that the distance of a galaxy is proportional to its velocity. So as you go twice as far out, turns out the velocity is twice as big. You go 3 times as far out, the velocity is 3 times as big. We live in a world, a big world, and a universe where everything's rushing apart, and it's happening in a way we call Hubble's law, where the velocity is proportional to the distance.
Hubble's startling discovery means that the universe is expanding, and that concept forms the basis of the Big Bang theory, which says that the universe began between 10 and 20 billion years ago from a state of enormous energy, density, and compression, and it has been expanding ever since.
3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
On April 25, 1990, the NASA crew aboard the Space Shuttle Discovery deployed the famous telescope named after Edwin Hubble. It orbits about 380 miles above Earth's surface. That high up, the Hubble can view the cosmos unobscured by Earth's atmosphere, 24 hours a day, 365 days a year. Technology has advanced since Edwin Hubble's time, but the work remains the same. The telescope's job is to collect images of stars in distant galaxies. These images help astronomers measure the age and size of our expanding universe.